All right, here we go, guys. Another day, another review session. Keep going here with a little bit of the CNS. Try to get through this again. Try to make these a little bit shorter and shorter if I can. So get CNS. That is the brain and the spinal cord. Sorry, phone just went off. PNS. Again, everything not encased in bone. So with that, you have the somatic nervous system and the autonomic nervous system. With the autonomic system, and again, I need to get that graphic out to you guys, but it breaks down into two parts. So you're going to have the sympathetic system, which is kind of fight or flight, excitement brought to the body, and then again with autonomic parasympathetic, rest and digest. Okay, so neurotransmission is any communication between neurons and cells. A few terms to know here: resting potential, that is otherwise known as polarization. That is the potential to start or produce action, for neurotransmission. Action potential, otherwise known as depolarization, is basically when a neuron is actually active and a neuron has been activated, that it is communicating, it's doing its job. Refractory period, which is also known as repolarization, that is basically before, let me think of a different way to put that. Okay, so basically repolarization can't really process two stimuli at once. Okay, so if two things are happening, you typically with like if you needed to, I don't know, hear something and then react, right? Smell something and react, whatever it might be. You have to finish processing. That neurotransmission has to finish for the first stimulus before the second one can take place. And if your body tries to do both of them at once, whatever second stimulus is occurring, you will process that far slower than the first stimulus. Okay, so postsynaptic potential, excitatory, that increases the likelihood of action potential happening, and inhibitory decreases the likelihood of that happening. As we get into neurotransmitters, you guys have plenty of notes on that, but as we get into neurotransmitters, excitatory and inhibitory, kind of like what we just talked with potential. Excitatory, again, that increases the likelihood of the neurotransmitter doing what it's supposed to be doing, whether that be blocking certain things, reuptaking, transmitting the way it should be transmitting. Sorry. Or inhibitory, which would be the opposite, right? That it is not doing what it should be doing. It is, instead of bringing in excitement, it is kind of inhibiting excitement. Activity would be another way to think of that. Stimulating, the mind or body would be another way to think about that. So you have neurotransmitters that are excitatory, that bring a lot of activity, bring a lot of action, bring a lot of stimulus. And then you have an inhibitory, which is the opposite, right? That it's more relaxation, it's more calming, and it's less about bringing, a lot of action to the mind or the body. So glutamate, you want to know learning, you want to know memory, and it's kind of the primary excitatory neurotransmitter. It is the most abundant neurotransmitter that your body naturally produces. Too much of that, though, because it is excitatory, too much of that is probably going to result in some brain malfunctions. It could be seizures, it could be strokes, maybe different brain diseases, but too much excitatory neurotransmitters are going to cause, things like seizures and strokes. GABA would be the next one. That is the primary function would be anxiety reduction, relaxation. It is the primary inhibitory neurotransmitter. So again, it is not trying to stimulate your brain. It is not trying to bring action. It is not trying to make it more stimulated. It is trying to reduce that, right? So when your brain or anxiety or stress gets going way too much, this is the neurotransmitter being transmitted to help you calm down, right? To reduce anxiety. A shortage of this obviously would be things like an anxiety disorder, increased levels of stress is probably going to impact your sleep. Again, too much might be seizures, might be insomnia. Anti-anxiety meds are designed to increase your levels of GABA. So, the drugs you take for anti-anxiety, you're taking that because your body is not producing enough GABA, right? Insomnia, right? You are too stressed, you are too anxious. And so sleeping is something that you really struggle with. Endorphins, that is basically your body's main painkiller. It reduces pain. It is released most often, endorphins are released in response to some kind of pain you are experiencing. It could also be released in response to vigorous exercise. Again, that kind of makes your body feel uncomfortable, so endorphins are released. Again, natural painkiller. You have things, and we'll get into agonists a little bit in a few minutes, but morphine would be like an agonist. Morphine would mimic endorphins. And so, people who, the natural amount of endorphins aren't enough, they would be taking something like morphine to help bring more pain relief to that person's struggles. Dopamine is pleasure and reward. We talked about before, like when you get that when you get that retweet or whatever it might be, you get that notification, kind of releases a little bit of dopamine. Maybe the excitement you get, the pleasure you get from riding a roller coaster, in that sense that you want to do that again, you want to get that rush again, that is dopamine being released in the body. Too little dopamine is going to be depression. You're more likely to be depressed, again, related to pleasure and reward. And too little dopamine might also have some kind of connection to Parkinson's disease. Too much dopamine, right? Too much pleasure, too much reward, too much of this kind of inner excitement is linked to schizophrenia. Serotonin, mood, appetite, sleep, impulse control. So knowing when to do this, when to do that, what is appropriate versus inappropriate. So serotonin, too little of that. Again, depression, and because it is with mood and appetite and sleep, a lot of your sleep disorders are connected to too much, too little serotonin. Norepinephrine, that is arousal and attention. All right, so norepinephrine, if you have the right amount, we've talked about that before. An appropriate amount of norepinephrine and arousal could have you really prepared to run a race, right? Really prepared to take the ACT. Too much could have you too anxious, right? And you come out for that race way too fast and you're going to crash. Or you're way too excited to take that ACT. You can't stop tapping your fingers or tapping your foot. You really struggle to pay attention, right? And not enough norepinephrine. Again, same thing. You're not ready to race. You're not quite functioning at that maximal output, or you're falling asleep during the ACT. Norepinephrine is also kind of your fight or flight reactions. So when you're presented with something scary, something that might for most people might energize them, for most people might scare them. Norepinephrine is that neurotransmitter that causes you to stay and fight, or to run away, to get the heck out of there. Last one, acetylcholine, ACH is the other way we have that. That is a lot of your body control, your muscle control, coordination, a lot of the physical stuff. It is also directly tied to memory and learning. Again, a lot of these neurotransmitters kind of tie in together. Too little ACH is going to be connected with Alzheimer's, right? So because ACH is directly, lending a hand in your ability to learn and your ability to form memories, too little of that Alzheimer's, right? And dementia and some of these memory disorders are directly tied to a shortage of ACH. Okay, that takes us into agonists and antagonists. An agonist is a drug. It is not a neurotransmitter. An agonist is a drug that mimics neurotransmitters. Okay, so drugs or toxins that increase neurotransmission by either mimicking action of something that is excitatory or delaying something that is inhibitory. Okay, so your agonist drugs, again, we talked about morphine, right? That morphine, your body is not your body is not producing enough endorphins. And so morphine would be a drug that kind of, mimics that pain relief. And you would be taking this drug, that mimics the excitatory, the pain relief. Antagonists are drugs or toxins that decrease neurotransmission, right? So if you were wanting to, sorry, phone went off. If you are wanting, again, to take, I don't know, something to help you sleep, right? You are struggling with, let's say, insomnia, right? And so you're wanting to take something to sleep. Antagonist would be any kind of stimulant that works against sleep, right? Antagonist would be, that could be blocking serotonin, right? So anything that acts against what you're wanting to accomplish with neurotransmission, that is an antagonist. So, looking here, other things you might want to talk about here with the CNET, again, Phineas Gage, coming back to that, his behavior change as a result of damage to the frontal lobe. So we do know that parts of the brain are responsible for certain aspects of our behavior. Broca's area, again, the left frontal lobe, production of language and speech. Broca's aphasia, struggle to produce or struggle to speak words as a result of damage to Broca's area. Wernicke, spelled with W, Wernicke's area, again, left temporal lobe, that is the comprehension, that is the understanding, coherence of language. And Wernicke's aphasia is problems with understanding, comprehending language, and making meaning of speech. CTE, chronic traumatic encephalopathy, that would be basically concussions, and brain damage. Chronic degenerative brain disease results from repeated head injuries. CTE, most famous, I think it was Will Smith had the movie kind of recently about CTE, and there were stories that like the NFL was trying to block the movie from being released because it made football look really bad. So players, who have been diagnosed with concussions, because you get paid millions of dollars to play football, they have repeatedly come back after those injuries, and they have been playing with concussions or with brain damage, and they have had early onset Alzheimer's, early onset dementia. They have lost, some of their motor skills, their motor functions, and a lot of it was because of this brain damage and playing through repeated brain damage. So brain studies. So with CTE, you'd want to do EEGs and PET scans and CAT scans, and we look at those already. So we're not going to hash those out again. I think we're probably good for what I wanted to accomplish with the central nervous system, with parts of the brain. We are going to get next into more drugs and stimulants and depressants and hallucinogens, stuff like that, and how those outside external sources can impact our brain. Stay tuned. Send some more stuff at you pretty soon, and send a couple assignments, and maybe kind of schedule our next live Zoom session that is going to be happening soon. Hopefully you guys are keeping up with the studies, keeping up with the notes, and making your way through that AP exam Google slide that I shared with you. All right, guys. See you.